Hello everyone. Next, I will share the conductivity and autohismicity of myocardium to you. The conductivity of myocardium refers to the ability or characteristics of myocardial cells to conduct excitement. Excitation conduction not only occurs on the same cardiomyocytes, but can also be carried out between cardiomyocytes. Myocardial conduction pathway 1. Myocardial fibers 2. Special conduction system, including sinoatrial node, dominant conduction pathway, atrioventricular junction, left and right atrioventricular bundles, left and right bundle branches, pulse fibers, ventricles. Excitation. The special conduction system of the heart includes sinoatrial node, atrioventricular node, atrioventricular bundle, left and right bundle branches, and the Purkinje fiber network. They are the important structural basis of excitement conduction in the heart. The electrophysiological characteristics of myocardial cells in each part of the heart are different, and the distribution, density, and types of gap junction between cells are different, which makes the conduction velocity of excitement in various parts of the heart different. 1. The conduction velocity of the atrioventricular junction is the slowest. 2. The conduction velocity of the pulse fiber network is the fastest, because the atrioventricular nodal area, the conduction speed is slow, and it is the only channel for the excitement to pass from the atrium to the ventricle. So there will be a time delay when the excitement passed through here, which is called atrioventricular delay. Atrioventricular delay is important physiological and pathological significance. It ensures that the constriction of the ventricle occurs after the atrial contraction is completed, which is beneficial to the filling and ejection of the ventricle. Structural factors. The cell diameter is large, and the conduction excitation speed is fast. The cell diameter is small, and the conduction excitation speed is slow. Physiological factors. The greater the speed and amplitude of the action potential, zero-phase depolarization, the greater the local current formed, the faster the threshold potential is reached, and the faster the excitation conduction speed. Membrane potential levels. Cell membrane potential decreases. The action potential zero-phase depolarization, amplitude becomes larger, and the conduction speed increases. The excitability of the membrane in the adjacent part is higher. That is, the gap between the membrane potential and the threshold potential is small, and the excitatory conduction speed increases quickly. Autonomy refers to the ability of characteristics of the myocardium to automatically produce rhythmic excitement without external stimulation. Cells that produce autonomy belong to a special conduction system. The autonomy of P cells in the sinoatrial node is the highest, about 100 times per minute, and physiological conditions, the total cardiac activity. It is carried out in accordance with the rhythmic excitement of the most self-disciplined organization. Therefore, the sinus node is the normal pacing point of the cardiac activity. The heart rhythm formed by the pacing of the sinus node is called sinus rhythm. Under normal circumstances, other self-regulatory tissues only perform excitatory conduction and do not show their own rhythm. Such so-called potential pacemakers only when the normal pacemaker's patient dysfunction or conduction is impaired. The potential pacemaker's patient effect will appear. It can replace the sinus node to generate transmissible excitement and control the activity of the heart. The abnormal pacing site at this time is called the ectomic pacing point. The main mechanism of the sinus node controlling the potential pacing points. 1. Preemptive occupation. The autonomy of the sinus node is higher than other potential pacing points. When the potential pacing point reaches the threshold potential before the fourth phase of automatic depolarization, the excitement from the sinus node has activated it to generate action potentials, thereby controlling the rhythmic activity of the heart. This phenomenon is called preemptive occupation or capture. Overdrive depression. When autonomous cells are stimulated higher than their natural frequency, they become excited at the frequency of external stimuli, which is called overdrive. After external overdrive stimulus ceases, the autonomic cells cannot immediately show their inherent self-regulatory activities, and it takes a period of inactivity before they gradually resume their own autonomic activities. This phenomenon is called overdrive depression, which affects autonomy. Factors include the speed of the four-phase autonomic depolarization, the maximum repolarization potential, and the threshold potential of the autonomous cell action potential. The four-phase automatic depolarization speed. The characteristics of the contractility include 1. Synchronous contraction, also known as the all or nothing phenomenon of myocardial contraction. 2. Large dependence on extracellular calcium ion. The effective infractory period of the myocardial cells without tonic contraction is particularly long, from the beginning of the myocardial contraction to mid-diastole, which ensures that myocardium always contracts and relaxed alternately, which is benefits the filling and ejection function are completed. 2. Factors that affect myocardial contraction or factors that can affect cardiac output, such as preload and afterload. Myocardial contractility and the concentration of extracellular calcium ion can affect myocardial contraction. The electrocardiogram is a waveform that reflects the electrical changes of the heart recorded on the body surface with an electrocardiograph. It reflects the bioelectric changes in the production, conduction, and recovery of the heart excitement. The human body is a large volume conductor, and each part of the heart is in the presence of excitement. The bioelectrical activity that appears in the body can be transmitted to the body surface through the surrounding conductive tissues and body fluids. The regularly electrical change that occurs during the heart excitement, recorded by placing the major electrodes on certain part of the body surface, is called an electrocardiogram. When recording the electrocardiogram from the body surface, the placement position of the guide electrodes and the line connected with the electrocardiograph are called the electrocardiogram lead. The recording lead system has 3 types of 12 leads, including 3 standard limb leads, 3 compressed unipolar limb leads, and 6 unipolar chest leads. The standard limb leads reflects the electrical activity of the heart in the potential difference between the limbs. Pressurized unipolar limb leads reflect that the electrical changes in the electrical activity of the heart in the certain limb. Unipolar chest lead reflects the potential change of the heart activity at a certain point of the chest wall. A normal body surface electrocardiogram is composed of a set of waveforms, that is to say, a P wave, a KRS complex, and a T wave will appear in succession every time the heart is excited, and sometimes a small U wave may appear after the T wave. Each segment of the electrocardiogram waveform reflects the depolarization or repolarization procession of different parts of the heart. As shown in the figure, the KIS waveform has a high degree of coincidence with the action potential of cardiomyocytes. The upper dashed line is the action potential, and the lower solid line is the KRS waveform. Their peaks overlap. In a cardiac cycle, the P wave appears first, which reflects the depolarization process of the left and right atria. The PR interval is the time occurred from the start of the P wave to the start of the KRS wave. It represents the time required for the excitement generated by the sinoatrial node to reach the ventricle through the atrium. The atrioventricular junction and the atrioventricular bundle and cause the ventricular muscle to start to excite. KRS complex reflects the depolarization process of the left and right ventricles. T wave reflecting the process of ventricular repolarization. The U wave may appear as low and wide wave at 0.02 to 0.004 seconds after the T wave, called U wave. The direction of the U wave is generally consistent with the T wave. The meaning and cause are not very clear. KD interval refers to the time from the beginning of the KRS wave to the end of the T wave, representing the time from the beginning of the depolarization of the ventricle to the complete repolarization. The ST segment refers to the line segment from the end of the KRS complex to the start of the T wave, represents the depolarization of each part of the ventricle. That's all. Thank you. See you later.